Alright, welcome to our 16th video in Unit 7. This one's talking about ionic radii, and, well, yay. So, like the size of an atom, the size of an ion depends on its nuclear charge, the number of electrons it possesses, and the orbitals in which the valence electrons reside. Like, everything deals with that. But ions occur when atoms lose or gain electrons, so that changes things a bit, but not a ton. So, when a cation is formed from a neutral atom, electrons are removed from the occupied atomic orbitals that are the most spatially extended from the nucleus, meaning the farthest electrons are the ones that are taken away first, not the ones that we place last in electron configuration. For example, if our final one is 4s 3d something, 4s is farther away, and we take away these first, even though we put them in there first. We take away ones farthest away. Also, when a cation is formed, you now have less electrons, which means there's less electron-electron repulsions. That also means that you all now have more protons than electrons, which means the pull of the electrons is now stronger. So there's a stronger pull, and there's less electrons, which ultimately means that cations are smaller than their parent atoms. Meaning, this is basically sodium. This is sodium plus. Basically, the more electrons you lose, the smaller they get. So, there you go. Cations are smaller. When electrons are added to an atom to form an anion, the increased electron-electron repulsions cause the electrons to spread out more in space. You now have more electrons. And also, our overall charge is decreased. There's now more electrons, which means the overall net charge on each of them is a little bit less. So they're pushing each other away, and they're being held less tightly to the nucleus. You've got a little bit more electron shielding going on. Thus, anions are larger than their parent atoms. Chlorine minus. Now, this is not necessarily to scale. We do kind of have the charges, but you got to remember that cations get smaller, anions get bigger. Now, as for when you've got multiple things of the same charge, well, we're about to talk about that. For ions carrying the same charge, ionic radius increases as we move down a column in the periodic table. Meaning, if we have Li plus, Na plus, and cesium plus, they all have the same charge, which means they all shrink, which means we just go off what they started with. So when they have the same charge, you basically compare them off the atomic radius trend. Same charge goes right back to atomic radius. So in this case, sorry, might as well finish that. There you go. In other words, as the principal quantum number of the outermost occupied orbital increases, the radius increases. So this means that as we gain or lose electrons in higher energy levels, our radius increases. But this is the same logic as atomic radius. Ionic radii and atomic radii are basically the same trend, except ions throw in the fact that sometimes they can shrink or grow a little bit. By the way, an isoelectronic series, we mentioned this before, is a group of ions that all contain the same number of electrons. This would be like calcium 2 plus, potassium plus, sulfur 2 minus, and chlorine minus. So isoelectronic means same number of electrons. All of these have 18. So in any isoelectronic series, all we got to do is list the members in order of increasing atomic number. Now, this would mean then that actually, as we go through this list, we have more protons. So, let's see, for example, sulfur 2 minus, chlorine 1 minus, potassium 1 plus, and calcium 2 plus. Now, they each have 18 electrons because they're isoelectronic. However, sulfur has 16 protons, chlorine has 17, potassium has 19, calcium has 20. That means that sulfur ultimately has more electrons than protons, so it's going to be pretty big. Calcium has more protons, which means a stronger pull. And what was that sound? Okay. So that means that ultimately sulfur will be bigger than chlorine, and thus we basically have our biggest one is first, our smallest one is last. There you go. Let's practice. So, as usual, try it a bit, then come back. Alright, so we have magnesium 2 plus and calcium 2 plus. They're both the same charge, which means we go off atomic radius. Calcium is one actual energy level higher than magnesium. Thus, that means that calcium 2 plus is bigger than magnesium 2 plus. Now let's compare calcium. We know that cations get smaller. Thus, calcium, might as well write it up here, is bigger than calcium 2 plus. And thus, you have that calcium is bigger than calcium 2 plus, which is bigger than magnesium. So actually, if I were to officially write it, I don't know why I'd rewrite this, you'd have it like this. There you go. That's ionic radius. Alright, so for some reason I actually didn't put these elements in your notes, so I'm just going to skip this example, cross it off, we're moving on. Alright, last one, you work on for a bit, then come back. Alright, welcome back, and kind of awkward that I literally actually did this for you. I really got to stop doing that. But basically our decreasing will be sulfur, chlorine, potassium, calcium. Sorry about doing your example for you. But again, that's ionic radius. Thanks for watching.